Okay, so this one is probably just going to be problem one because it's a rather extensive problem. We're on homework 2, problem 1. You'll see that we need to build a model that takes into account the 30-year mortgage, and the payments are going to be, even though the payments are due at the end of the month, they're actually made on the first work day of each month. So you've learned in prior classes how to calculate payments, how to calculate interest, all kinds of stuff. The big thing in here is calculating, the first work day of the month. That's the one that's new for us. Okay, so we're going to go over here. These orange cells don't matter. You just need to put some amounts in there so we can work off of them. So let's put a $450,000 loan. I want to make it a number just because that's easier for me to see. We're going to have let's do a low APR, 1.9. Now this is 1.9%. If you do not have this formatted as a percentage, be aware that if you just go like general, see, that's 0.019%. If I make it 1.9, that is a shit ton of interest. Because if I hit the thing, that's 190% interest. Okay. Just be aware of that when you're doing your calculations. So if your monthly payment seems really big, it's probably a formatting thing. Okay, but we want 1.9% interest. And the loan date, let's just say today. So September 8th, 2022. Okay, so now we've got all these things. You can see here that I have labeled them. So my loan amount is loan amount. My APR is APR. My loan date is loan date. Okay, so that way we can now refer to those three things. The next thing we're going to want to label is, okay, if I Control Shift down, it takes me to the bottom here. And I don't want this one. I added this row. I'll explain to you in a minute why. Go away. Anyways, so we've got this column. You can see I've labeled this column payment number because I'm going to need to know stuff about this column. And it's going to be relevant later, but I've named it payment number. Okay. So when we do our monthly payment amount, we need to know how many payments we're making, and we're going to look that up in payment number. Okay. Now you can do that, or I know that also what you can do is when you're looking up like number of payments and stuff, because this column is not orange, so you don't have to worry about it. You can just click this cell down here at the bottom and be like, find me that number. So either way, there's multiple ways to do this, but we're going to do it with this one. Okay. Next thing we got to do is figure out our monthly payment amount. Okay. So if you remember from accounting and all of those other stuff, a loan is actually negative. Like this should be a negative number. However, people don't think that way. So we're going to have to account for that in our model. So before we do our formula, we're going to hit negative so that it'll return a positive monthly payment amount. Okay, because we're going to use a payment calculator, and just the way the payment calculator works. Now, you can either do that, or I'll show you later on in the formula, you can choose to make the loan amount negative, and that'll do the same thing. It's just like when you were working with your financial calculator, you had to remember to make one of the things negative so that it worked properly. Okay. So we're going to use our payment function, which calculates the payment for a loan based on constant payments and a constant interest rate. We have constant payments, interest rate. That's exactly what we want. Rate is going to be our APR up here. Now, monthly payments, APR. APR is annual percentage rate. So in order to find our monthly payment rate, we got to divide by 12. Okay. You remember that from our financial stuff. If you're calculating a payment, you have to keep in mind the, how often you're making the payments. We're making monthly payments, it's going to be divided by 12. If we were making quarterly payments, we'd be divided by 3. Bi-yearly, biannual payments would be divided by 2, blah, blah, blah. Okay. If we were making a payment every single day, it would be divided by 365. All right. So we got our rate. Now we need the number of periods. Okay. This is where our payment period thing down here is going to come in handy. Now, what we could do is just click this cell, and this cell would basically tell the calculation 360. Okay. Or what we could do, if you know, this column was, you know, relevant or something like that. You know, we could have selected this entire column and made this entire column labeled payment number. And then in theory, you could add as many add or subtract all the payment numbers you wanted and search for the highest number in that column. And that would return the correct number of periods. That doesn't matter here. They're not orange, so that means they're not going to change. But we're still going to do max. And I want the maximum in the payment number column. Okay. So max is going to return me the highest number in this payment column. Again, if I wanted to be able to add and do like a 40-year mortgage or a 25-year mortgage or whatever like that, and add and subtract columns at will, then I would make this whole column be labeled payment number, and then it would always find me the correct number. All right, so we've got payment number, and now I want the present value, which is our loan amount. Okay, so close that out, and we're gonna hit enter. Okay, so over 30 years, if I pay $1,640.87 every single month, I will pay off a $450,000 loan eventually in 360 months. Okay, for total interest, that's basically going to be the sum of this column. Okay, so because we're going to eventually calculate out how much interest is compounding every month, and we're going to figure that out. But so this is going to equal the sum of our interest column. Okay, I've labeled it interest. You can label it, you know, F13 through F372 or whatever it is, however you want to do it, but it's just the sum of this column. Remember, do not add the label. Okay. Okay, it's going to be 0 for now because I got nothing in there. And the last payment date is going to be that whatever day that we populate in right here. I'm going to delete this for now, and then I'll redo it later to show you guys. So whatever date populates right here is the date that we want. Okay, so that's 372. So you are just going to equal the 372. Okay, and it's already formatted for date. Make sure all your dates are formatted for dates, otherwise you'll get weird numbers. But see, that's our last payment date. Okay. Now, we need to figure out what the first day is. We can't even worry about the last day yet. We got to figure out the first day. Okay, so we want the first work day of each month. There's your hint. You're going to use the workday function that we just learned. So we're going to equal the workday. Okay. We can do Workday International, which Workday International, as they explain, and you want to pay attention to if they want your weekends to be different, like maybe your weekend is Sunday and Monday, or your weekend is Monday and Tuesday, you know, and you work some other shift other than, you know, Saturday, Sunday weekends, Workday International will matter. But for now, we want the serial number for the date before or after the specified number of work days. Okay, so all right, now we need to figure out the start date. Now, if we just click the loan date here, that's going to make the first work day after this start date. And that's not what we want. We want the first work day of the following month, because our first payment, if our loan date is September 8th, our first payment is going to be October 1st, presuming that's a work day. So we want the first work day in October. Well, in order to do that, we got to tell it what the start day is. And so we're going to use this loan date to look that up. So we want to look up a date, okay? Returns a number that represents a date, okay? So we're going to use this date function to tell Workday what day to start, all right? And I want a year. Again, I can't just click the loan date. I want to now parse out the year from the loan date. So if I use the year function, returns the year of a date. So if I do year and click loan date, it will return just the year, which is what I want, okay? Now I want the month. I'm going to do the exact same thing because I want the month of the loan date. So we're going to do month of that loan date. Okay, so now I have the year and the month, but do I want the current month? Because that's going to, if I just do this, This is going to give me September 2022. I don't want September 2022. So I want to add, remember, you cannot hard code any numbers. Don't add one. You want to add the month of the payment. So I want to add the first month after, okay? So this is your 0 date, essentially. This is your T1 date, all right? So I'm parsing out my year, I'm parsing out my month plus 1, and then when we pull this down, the next month is going to be plus 2 months, plus 3 months, plus 4 months, all the way up to 36 months. And that's how Excel is going to figure out what the month is just by taking the original date and taking the first workday of the nth number of months afterwards, okay? And then for day, I just want the first workday, okay? Because, and this one is okay, because it's telling it the first workday. I'm not actually giving it like a number, all right? And then we're going to close that, and we're going to comma, and I want the first day of that following month, okay? And then I'm going to close that. All right, well, let's see how that looks. October 3rd, that looks good. Yep, October 3rd is a Monday, that's correct. Okay, let's see what happens when we copy this down. Oh, that's not what I want. Look, this has got September 4th. There's no way September 4th could ever be the first workday, because that means if it's Monday, September 4th, then the Friday was the first. We don't have the first on any of these. Okay, so we need to make an adjustment. And if you remember from his lecture, what we want to do when we make these adjustments is we're going to put it here because we're going to affect the workday. The issue here is the date. This right here, this section is the thing that's giving us trouble. We want to adjust this. We don't want to touch this one here because the one here is giving us the first workday. Okay, we want to change the date that it's looking up. So we're going to add, because we're 1 day too high, we're going to put -1. Okay, tiny adjustment, -1. This is going to stay the same. But when I double click, there we go. Now I've got November 1st. Now I've got December 1st. And then if I look up, you'll see that New Year's is on a Sunday. So January 2nd is the correct day. Okay, so now all of these are correct. And then we can look, now that our last payment date has populated, we can see that it's the same month, just 30 years into the future, which is exactly what we would expect to see. Perfect. That's exactly what we wanted. Okay, now we can move on to our balance. What's our beginning balance? Well, that's just going to be our loan amount. Okay, that's always going to be our loan amount. What's our payment? We already figured that out. This is going to be our payment, constant payments. For 30 years, we're going to pay not but this. Okay, that is going to be our payment for 30 years. So if I hit enter and then I can double click all the way down, that's what it's going to be. I obviously can't loan amount all the way down because I want to take into account that I paid something. Okay, so I have to figure out our ending balance here, and the ending balance here is what's going to go there. So I can just put that in, that this is going to equal that. Okay, and then I can just double click that all the way down, and each time it's going to be the ending balance after my previous month's payment. Okay, that's what I want. Okay, so now what I'm going to need to do is figure out how much principal our payment, like how much of our payment is going to principal and how much of our payment is going to interest every month. Okay, because what will happen is you're going to have your beginning balance minus the amount going to principal is going to be our ending balance, and then interest is just the, you know, the stuff your bank is taking off the top. You know, interest is you getting the shaft. Luckily, we got a really small amount of interest. So our ending balance is going to be our beginning balance minus the amount of our payment going to principal. Okay, and that's going to be all the way down. So for now, it looks like 450 because we haven't figured out how much of our payment is going to principal yet. Okay, so we need to figure that out. Once again, the loan amount is technically negative. Like I forgot to show you up here, you can get the same thing if you put the negative sign here, or if you put the negative sign right here and put like negative loan amount. You'd probably do that too, but it's just easier to put it at the front. Just make life easier on yourself. So we're going to do the same thing here because we need to flip the sign. Otherwise, I'll show you and it'll just, this principal will be negative and then it'll make everything really screwy. So let's pretend that we forgot to put the negative sign, okay? So we want to calculate our principal payment. So that is PP, returns the payment on principal of a given investment given periodic constant payments and a constant interest rate. That's exactly what we're talking about here. And this is for an investment, but it works the same way, but with a loan. So we want our principal payment. The rate is going to be, again, since this is monthly, it's going to be our APR divided by 12. Okay. And then we want the period that we're in, which is going to be this period. Okay. Now, you don't need to do an absolute. You don't have to do dollar signs in here, because when you click it and go down, you want this number to change all the way down to reflect the current period that you're in. Okay. Then we're going to want the total number of periods, which we'll do the same way we did the payment amount, which is just max and then payment number. So it'll look for that for us. Okay. You could also, again, just point it at that very last cell down at the bottom. That is totally a thing you could also do. Okay. So max payment number, and then our present value. Now this is going to calculate. It doesn't calculate off of the amount due. It calculates off the original amount of your loan. So your present value is always going to be your loan amount. Okay. It's not the beginning balance. So you don't want to refer back to this beginning balance. You want to refer back to the original loan amount because of per and n per here. So your current period and your number of periods, because you're telling it the current period, that's going to take into account like which month it is. So that's why you don't want to use beginning balance. You're going to throw this off and it's going to come out with a really screwy number. Okay. So remember that the present value is going to be your original loan amount because you're calculating this into the future. So your present value is how much you took out of a loan today, not how much you're going to owe at the next period. Okay. Then we're going to close that out. Oh, look, it's negative. Remember what I said? There you go. That's what I'm talking about. If you have to remember to put that negative sign in because loan amount is assumed by Excel to be a negative number. Okay. So now we can see where we've done this principal and we've got our next month and see it's all the same. And then we just double click and you can see it all the way down. And it's going to calculate out all the way down to the bottom when you make your very last payment in September 2052. Okay. And then your final ending balance is 0, which is what we want to see. That means it's working correctly. All right. Now, you don't technically need to know how much your payment is going to interest, but it has it up here that it wants to know. So, okay, fine. Let's figure it out. Also, you could, in theory, do payment minus principal equals interest. You could totally do that. You do equals payment minus principal. That is a thing that you could do. And then these two together equal that. That's perfectly acceptable. I'm sorry. These two together equal that. That's perfectly acceptable. That's a thing you could do. You could just scroll all the way down. It gives you money. So on this $450,000 loan, you actually end up paying $140,000 worth of interest. Woo, student loans, am I right? And then you can see here where the amount of money going to principal and the amount of money going to interest flip-flops. Like the amount of money going to principal goes up and the amount of money going to interest goes down as your balance goes down. And you see all the way down here, you know, the very last payment, only $2.59 of it is paying off interest and the rest is pure principal. Okay. You could do that, or we can use, remember how this had the principal payment function? There is also, actually, don't do this. I'm going to do this just for illustrative purposes, just to show you it comes out with essentially the same thing. You have an interest payment. So it's going to be the exact same as the principal payment, but it's going to give you the interest payment instead. So I want the rate divided by 12. I want the period. I want the max payment number for the total number of periods. And I want my total loan amount. And haha, make it negative. And see, it's given me the exact same number. Okay. So you could literally do either one. You could do the very simple one, principal, or I'm sorry, payment minus principal equals interest, or you could do interest all on its own, and you will get the exact same numbers. You will get the exact same sum. You will get the exact same answer. So it'll still work, and it's perfectly fine. Okay. Either one you want. Do not add an extra column though. I'm just gonna delete this. Okay. And that's it. That's our finished sheet. We've got all of this stuff in here. Now, you can play with it and make sure it works correctly. What if our APR was more expensive? What if it was 2.9? Oof. Now we're gonna have $224,000 of interest on our $450,000 loan. We're gonna be paying $1,800 a month. And it's going to take us still the same amount of time to pay it off. But you can see here, our interest payment has like almost doubled. You know, even the very, very last one, instead of being like $2 and change, now it's $4 and change. Okay, so everything's working correctly. And that's it. I hope this helps.